We're going to do all fisheye lens MacBook repairs from now on. We have a 16-inch brought in from a shop for a board repair. Onset, it's very dusty. We have a pretty good idea of what the problem is, and what kills most of these 16-inch MacBooks is that you have an SSD controller on the back side of the motherboard. So these get all sort of caked in like this, and then a little bit of moisture develops, and then Apple thought it's funny to put an SSD controller with a very high voltage line for the main power rail next to a 2.5 volt line for the onboard storage. And as it turns out, fire hose into bendy straw is not good. And this is very, very common failure on these machines. The first thing we're going to do is just dust this out, and then we'll take it apart before we even start to run power through it. In any case, we were already they tried the usual things, but yeah, it's just super, super caked in on these. Another thing too, just with any of these Mac machines, there's no dust filter or anything like that, so these have pretty wide gaps about the end of this guy, so fairly large debris can get in here and build up, and certainly all the dust does, and people have these, and they never take them anywhere to get cleaned out every once in a while, and then you get this sort of issue. We'll take it apart, look at it further. We're gonna dust it out first, and then we'll get right into it. Okay, so this board is pretty dusty. We got it out. I kind of cleaned it up a little bit further, but the main area I wanted to look at was around this SSD power controller thing. We do have some spots that don't look good. I think this inductor is a little corner of it kind of blown off, or is that just some it's just a little bit of rust. All right, a few of these caps don't look too happy. This did have a good amount of dust over there. I just want to check we don't have like a very low resistance short to ground on some of these, or more importantly, that our PP bus isn't shorted to our 2V5. It's basically what happens on this chip, right, is we have this line here, 2.5, and we have 13 volts right here, or you get this line shorting to ground here, or whatever over here. So I already kind of checked around here. Nothing doesn't really look too worrisome, so I think we'll run power through the USB-C port finally and see what it does. We can just check our resistance to ground over here. 340, 390, nothing really really crazy. And then when we check our 2V5, the PP bus, we're getting fairly high resistance, which is good. That means we don't have a direct short under the chip right now. We could have earlier with the dust, but now we've basically made sure there's not you know, we're not going to run power through it and kill the storage, basically. Oh, you know what? I'll need to grab a port for this one moment. I have all of my silly softwares running. Let's see what this does. It's 5 volts, 20 volts, 0.5. This almost seems like it's turning on. And I'm going to check thermal cam still. Let's see what we see. Oh. Alright, so it's actually our top side little SSD controller. This is getting 20 volts, quite a lot of current, but we can see that this thing's getting 140 degrees Celsius, so let's see actually what we have there. Just never see the top side one fail. We're just going to remove that chip, but let's check over here too. Let's see what we're looking at. That's not what I wanted to do. Same lines. This probably is. Yeah, our PP bus is probably going to be short into something in here. So okay, so we have our 2B5 shorting to ground. Okay, let's remove this chip and see how our resistance on this guy changes. Right now we're getting about 2 ohms to ground, which is way too low. Let's get this guy off. Grab a replacement chip. Well, we basically don't really see our resistance change all that much when this chip is gone. Then our NANDs are probably dead, unfortunately. This person's stuff would be gone. Let's see. We can go ahead and do is just put something on top of the NAND as a just in case. Let's clean up the solder there. Let's see what we get now. We're basically not still getting very low measurement. Yeah, so we're up to, okay, so that looks good. That's promising. We got 2 ohms now. We're at about 1,000. It's probably kind of jump around as the board. The board's pretty hot right now. It'll cool down. But this might still be okay, which is nice. That's really what we had, is this shorted to ground, not, to this 13 volt line, basically, which is really, it's a toss up. I feel like maybe 40 to 50% of the time this just has dead storage, basically. Because most of the time, person's using the computer, it suddenly doesn't turn on. They didn't spill water on it. They just had, a dusty MacBook, basically. It's not like they, really actively damage it in some way. This is just designed in a stupid way, basically, where you have, very high voltage next to low voltage. It's similar to how on the screen connectors, Apple will put a backlight line next to a 1 volt data line that goes into the CPU or the MUX or, whatever. Not to say, Apple's not the only one guilty of doing that. A lot of manufacturers do shit like that, unfortunately. We'll get a new chip on there, and then we'll test it. This will probably work. We shall see. I'm going to grab a chip. Okay, so we got our replacement chip. Really, for this area, I'm just going to get leaded solder over the pads. I don't really need to bother wicking this. It's a pretty small chip, and we can get enough evenness by just kind of getting some leaded solder on this, really. You can go in with like hot air and get it. I just kind of find it unnecessary. I just don't like to do a bunch of hot air near the NAND IC if I don't need to, so we're just going to kind of go minimal heat approach in this area. Okay, we'll get our new chip out. This is something that you should definitely stock if you're fixing boards. It's a very common chip to fail, not just for this particular problem, but this chip's basically a buck regulator, so I think it's like a what would it be? Multi-stage? Whatever the technical jargon is. It's basically, it looks like it's bringing down voltage for 2 lines. So it's taking that 13 volts of, oh, I don't have my thing open. Let's switch to this. Right, so this guy's taking, it's a 12 volt line, 13 volt PP bus, basically, G3 hot voltage. Takes this, goes in here, does some, sorcery. Who knows? Who knows what's going on in here, right? No one really does. And then it turns it into 2.5 volts. Then we have these, inductors doing magnetic resonance, yada yada, gives us 2.5 volts. Powers our 2.5 volt NAND line. Really though, this is just a buck converter. So this is, effectively a few MOSFETs in here inside of this chip, and they're doing their MOSFET stuff, and then we get our lower voltage on the other end. And really what's just bad with the chip is just the pins are just close proximity here, and really if the machine didn't get dusty, it doesn't matter. A good solution on these, and what we'll do once we actually fix this, is basically cover this chip with a glue so it doesn't get crap under it again, and this doesn't happen again and kill the storage. This one, it seems like the storage is going to be okay, but the other half the time I see these and all the one of the chips dies or multiple do, and all the data's gone, and there are actually some people replacing the NANDs on these. It's a bit of an involved process, but it can be done. But data is not retrievable, which is a bummer. So this does happen fairly regularly. Get our new guy on there. Where's our pin 1? I am all backwards on the board view. Just want to flatten those out a little. up my airflow now. It's already kind of in place. I saw everything kind of swoop into place. Oh, I didn't really have that center. Now we will let the board cool down, and we'll see if it works. Fingers crossed. The MacBook seems to work now. Obviously, we have a hotspot there because I was, shooting hot air. But we don't, see anything out of the ordinary. None of that. These don't really like not having their battery plugged in, but this should work now. So I'm gonna unplug power, and we are going to put some glue around the two SSD controllers on both sides of the board so that this doesn't happen to this person again. We're gonna dust it up so this comes back again and we can get more circuit board repairs. I'm gonna dust that MacBook up. Okay. So let's clean off the flux on the board just with, this is really unnecessary to ultrasonically cleans. Just had dust on it. It didn't really have any corrosion. We replaced one chip. Get some hot air at 140, 120 airflow. Get a clean brush. Just get all that flux out of there. All right, clean. We will get our blue UV glue. This blue is fancy. Put some of this there. Put some of it there. Just all around this guy. We're gonna cover him up. Just use a pair of tweezers to kind of guide around the glue. Does not need to cover the whole chip. Honestly, you could just kind of put a big glob and just take a Q-tip and take some off the top. You still want the chip to be able to like dissipate heat to a degree, right? So kind of same idea as the NANDs that are around here. Those have underfill, but they said, fuck it on this chip. We'll let it breathe. Alright, so I'm just gonna take a little bit off the top. And we're gonna do the same thing. Oh, I didn't really point at what I was doing, but we're putting some UV glue around the chip, and then we're gonna put a UV light on it to cure the glue. And this will basically prevent this issue from happening again, which is fun. We're doing preventative, maintenance. We're putting a helmet on the MacBook. And then there's another one of these chips on the back side of the board we'll do the same thing with, and then we're gonna put it back together and test it. I think it'll work. I sure hope so. We'll see. So this is your standard yippee moment. It does seem to be working. We get to the login screen. That's cool. It's running power. Very, very nice. We're just going to run Apple Diagnostics on it, basically. But this should be okay. I have this here just to cover the person's name. So we don't want to give out anyone's info. This should be a happy MacBook, though. We're going to do some testing and just make sure. And we'll be right back. You know what, for the speakers on this laptop made like a sad noise when it started up, but now they sound fine. I thought maybe the speakers were blown out. That does happen sometimes when these are really dusty. This seems okay. It passed Apple Diagnostics, goes to our login screen. We were given a password. It doesn't work, so we're going to wait to get the correct password to, fully mark it as ready, basically. But this should be all good. This is a really, really common problem on the 16-inch MacBook Pros. It's the most common issue on this computer. But effectively the issue itself is just like dust buildup, which is a problem on every Mac. In this case, it's probably the most unfortunate dust buildup because it is on a power regulation chip for the storage, which is all on board. So it can fail in a way, and does fail in a way pretty often, where it kills the onboard storage, rendering the data unrecoverable. This one seems to be all good, though. So this is one of the lucky ones, basically. So it'll continue its MacBook duties for a while, and then what we also did was just cover those SSD controllers with glue, basically, so this will not happen to it again. Ideally, hopefully we never see this MacBook again, but we will see you in the next video. Bye bye.